Okay, so this is the second part of this section, and it is for non-homogeneous DEs, and we're going to use variation of parameters. So here's a non-homogeneous differential equation where f is a variable vector. Our solution is still the same. Okay, so when we have the fundamental set, we make the matrix out of the fundamental set, and we call it phi of x, which is the fundamental matrix. The general solution for the homogeneous XC is the fundamental matrix times C. And so here's what it looks like. So our first note is that the fundamental matrix is non-singular, and that's because it's made up of independent solutions. And if you remember, that set of independent solution actually is the Wronskian. The determinant of that. So since we have, this is just the non-homogeneous equation right here. If this is true, then for each of those x's, that's going to be true. You're going to sum them up, and we'll get the phi, the derivative of the fundamental matrix is a phi of x. Since the fundamental matrix is non-singular, what that means is the inverse exists. So C will equal to, I take the inverse of both sides. And the reason why we like to do this is if we're given an IVP, an intermediate value problem, we can find all the C's using this formula. So if you remember, when we were doing the homogeneous solution, and our fundamental set was y1, y2, that's our yc, and then our particular solution was u1 and u2. And then we had a formula for variation of parameters to solve for u1. So that's what we're going to do. We're going to replace. So our C so our XC is defined to be phi of C. So our XP is going to be defined phi of U. So remember we need to find this and plug it in. They're both in terms of t, they're both variable, so we have to do the product rule. Okay, so just to keep our eye here, we're plugging these two in on the left. And if you remember above on our note number 2, we have this. So we'll replace that with that. And it looks like those will cancel. And remember, phi inverse exists. So this is U. So this will be a column matrix when you multiply them. And to integrate, you integrate each entry in the matrix. Then you put it together. XC is from above, phi times C plus XP, we just found right here. Okay, so let's write out the method. Okay, so first we find our eigenvalues. We write out our fundamental matrix. You find your phi inverse, and then you find the product, and then we have U equals the integral of that. Phi U. So again, we have, that's our XP, that's our XC, that's our XP, just like the other variation of parameters. And this one, sorry, that's dt. And that would find your C's if you're finding a particular solution to the non-homogeneous. Okay, let's do our example. So here's our system. That's a T. So this can be written as x prime. We'll just call it x. So let's remember that's supposed to be your lambda. That's why this one was 0 here, because lambda is 0. So my XC we can write that as a matrix. And again, this just came. So this times this for that, and your C1, C2 is there. So just another way of rewriting it. This is our phi. And we can just type this into the matrix calculator to get the inverse. So this is number 3. U prime, there's the formula, there's phi inverse. And then our F, I think it was T, I think it was 1. If you remember correctly. Yeah, right here. So we're F. Multiplying those. Just do this times this for our first row. And then this times this for our second one. Again, this is a 2 by 2, 2 by 1. This will be a 2 by 1. Second row. So U, the integral. Again, this is my ft, v inverse f. And we can just integrate that. And we do have to integrate by parts here. And so this by parts, this one right here, uv, and then the integration of that, minus and minus is a plus, but then we have to integrate this. That's going to be a minus. And then finishing this off, integrating that. And we do have to chain rule this. That's already there. That was already there with that is 1/4. That's how it became negative. Okay, cleaning this up. And when you combine that and that. Okay, cleaned up a little bit. So now we're ready to write out our XP. Our XP is phi, which is phi integral of phi inverse f dt. But basically, we found our u, and we know what our phi is. Our phi. Then my u is right there. And just so you know, this is our u1. That line is our u1. That line is our u2. Because we could multiply this out. But before I multiply it out, I want to work with it a little bit, putting back in u1 and u2. u1 times this one. Or we write it like we just did here. So like I said, this is my u1, and then this is my u2, like here. And if we wanted to, we can even write this out as this times this on our first one. My second row is my second row times that column. But of course, we do know what u1 and u2 are. But for brevity, I'm going to write out our general formula. So remember, it's C1. There's my XC, my XP. So you can see here, I just wrote this several different ways. But we have our u1, we have our u2. I'll let you plug that in. That's our answer. Well, I'll just write where u1 That's it for today.